Hello, I'm Emily Vasarhelyi, a PhD student at the University of Georgia's Institute of Plant Breeding, Genetics, and Genomics, and today I'll be demonstrating screening soybeans for resistance to soybean cyst nematodes. Soybean cyst nematodes are the biggest pest in soybean production, causing over $1 billion of economic damage in the U.S. yearly. The best defense against these nematodes is breeding resistant plants. To breed more resistant plants, an accurate method to screen for resistance is required. So that is the purpose of this video. To understand how we screen for soybean cyst nematodes, we need to know a little bit about their life cycle. So the soybean cyst nematode starts out as an egg, it hatches, and then it will infect the plant and feed inside of the root. When the adult males mature, they leave the root, find a female, and fertilize it. After fertilization, the female will become engorged with eggs and then turn into a hardened cyst full of hundreds of eggs. And that is what we count to determine if a plant is resistant or not. This video is going to cover root preparation, cyst collection, cyst counting, and rating for resistance. This video will not cover the test setup or inoculation. The materials for the root preparation are plants that are 25 days post-inoculation, a bucket, and a container to hold the root. The materials needed for cyst collection are 2 sieves, a size 60 and a size 20, along with a petri dish, a squirt water bottle, a beaker, your root sample, and a sink for blasting. Materials needed for cyst counting are a dissecting microscope, a pick, a counter, and a plate with lines to hold your petri dish. The first step in screening for resistance to nematodes is to prepare your roots. And to do this, you take your plants that were inoculated 25 days ago and cut them down to the base, leaving about 1 inch of stem just for holding on to. Next, I bring my containers over to a sink with a bucket full of water, and I'll gently remove my plants from the containers to get to the roots. And I then dunk the roots into the water to remove the soil. If you want to make this process easier, you should soak the containers in water before doing this. Here I'm having a difficult time removing the soil, but you don't want to be too rough and knock the cysts off. I then dunk the roots in a fresh bucket of water that I cleaned between each sample before I put it into its container. I make sure that the container has its label so we know what plant we are working on. And then I put it with the rest of the root samples that I have processed. Now it's time to collect cysts. So I head over to the blasting sink where I have 2 sieves. I have a fine mesh 60 sieve that goes underneath a more coarse mesh 20 sieve, which I put my root sample on top of. I use a high power blast of water to knock the cysts off into the finer sieve. I do this by going over the root up and down 3 times on each side. It's important to stay consistent between each and every root sample. I discard the root and remove the more coarse sieve. Then I use the water to bring all of the debris in the finer sieve down to one side. I grab a beaker to put all of the debris into using my water bottle. And there's a lot of soil left in the sample, which will make it hard to count. So I decant the sample by spinning a little bit of water around. So I'm pouring out the cysts and trying to leave the soil behind in the beaker. Then once I'm done with that, I put my sample into a petri dish. Now it's time to count our cysts. You can see them with the naked eye in this petri dish. They're the little yellow specks, but they'd be pretty hard to count. So we put the petri dish in this lined plate to make it easy to count under the compound microscope. Once I bring it over to the microscope, I just go line by line, clicking my clicker every time I see a cyst, and this is what the cyst looks like under the microscope. If one's close to the line, I use my pick to move it. Once you're done counting cysts, it's time to determine if your plants are resistant. And to determine resistance, we use what's called a female index. A female index is when you use a percentage based on a susceptible check, and if you have less than 10% cysts compared to the susceptible check, then your line is resistant. That's phenotyping for SCN. Thanks.